Hey folks, this is 4.2. We're gonna try to answer the question, how do I factor out a greatest common factor? Greatest common factor. That's probably gonna be referred to from now on as a GCF. And how do I factor by grouping? Two different processes, but factor by grouping is going to use GCFs quite a bit. So factoring a polynomial is rewriting the polynomial as a product of polynomials taken from a specific factor set. And when we factor polynomials, we always look for a GCF first. So what we're starting off with today is going to be a key step anytime moving forward with the rest of Chapter 4 and a lot of Algebra 2 moving on past Chapter 4. Factoring is a pretty concrete and important part for the rest of the school year. We'll see it many, many times more. So factoring out a GCF, you look at the terms in a polynomial and you ask yourself, what numbers go into the coefficients? What number can I factor out? And you also see if you can factor out a variable. So first of all, for the numbers in example 1, I have 15, 10, and negative 25. 5 goes into all three of those numbers. Then look at the variables. Well, the first term has an x squared, next term has an x to the 1, and the third term doesn't have an x. So they don't have an x in common. There is no common factor of an x. So all I can do is factor out a 5. Now you make your parentheses. This is really reverse distribution, by the way, folks. We give you a distribution problem, and you multiply it together to get something that looks like this. Now we're going to factor this, and it's going to look like a distribution problem. That factoring part for the distribution problem is the answer. So to figure out what goes in those parentheses, divide everything by the GCF, divide everything by 5. And the answer to this division is what goes in the parentheses. So 15x squared divided by 5 is 3x squared. Drop down your plus sign, 10 divided by 5 is 2. That one has an x, so it's 2x. And then drop down your minus sign, 25 divided by 5 is 5. Close your parentheses, and there we've factored or taken out the GCF from that polynomial. Next, example number 2, 6, 6, and 15 can factor a 3 out of that, but notice that last term doesn't have an x, so we can't factor an x out of there. So we take our 3, put it out in front of the parentheses. What goes in the parentheses? Well, do this division to figure it out. 6 divided by 3 is 2. The x to the 5th comes along. Drop down your minus sign. 6 divided by 3 is 2. Drop down your x to the 3rd. Drop down your plus sign. 15 divided by 3 is 5. There we are. Let's try number 3. All right, so what number goes into 8, 6, and 4? That would be a 2. But now notice, this term has an x to the 5, this term has an x to the 3, this term has an x to the 1. So they do have an x in common, but you can only factor out the smallest power that you see. So that's a power of 1. I can factor out x to the power of 1. What goes in the parentheses? Well, to find out, divide everything by the GCF, by 2x to the 1. So my first division, 8 divided by 2 is 4, and then x to the 5th divided by x to the 1 is x to the 4. Drop down your minus sign. 6 divided by 2 is 3. X to the 3 divided by x to the 1 is x to the 2. Drop down your plus sign. 4 divided by 2 is 2. And then right here in the highlighted area, x to the 1 divided by x to the 1. Whenever you divide something by itself, you just get 1. Or essentially it cancels out. So we just have a plain old 2 there. Which should also make sense because, again, instead of doing this division, you can just make sure, all right, 2x times what gives me 4x. 2x times 2 gives you 4x. When I multiply, that's how I check my factoring, I do get that third term, so it's correct. Example number 4, what number can we factor out of 3, 15, and 12? 3, 15, and 12, that'd be a 4. So let's pull a 4 out. Oops, and I started making parentheses, but no, don't jump the gun. We should be looking for x's. Can we factor an x out? X to the 7, x to the 5, x to the 3. The smallest power, they all have x's in common, so I can factor out an x, but only the smallest power, which is x to the 3. So now, divide everything by 4x to the 3rd. We get, no, Mr. P. We're factoring out a 3x to the 3rd. Three x to the 3rd. So 3 divided by 3 is 1. You can write a 1 there if you want. And then x to the 7th divided by x to the 3rd is x to the 4. You subtract those powers. Drop down your plus sign. 15 divided by 3 is 5. Subtract the powers. It's going to be x to the power of 5 minus 3 is 2. Drop down your minus sign. 12 divided by 3 is 4. And then again, we have x to the 3rd divided by x to the 3rd. That's going to cancel out. So there we are. All right, let's try some factor by grouping, folks. So we're factoring a 4-term polynomial. So in this polynomial that we're about to factor, there is no GCF. They can be pulled out of all 4 terms, but the first 2 terms has a common factor, and so does the second 2 terms. So really, we're going to go from this problem. Our next step is going to be to group the first 2 and to group the last 2 like that. Then you look for a GCF in this binomial, which is x squared, and then you're left with x plus 2. And then you look for a GCF in this binomial, which is 3, and then you're left with x plus 2. Now notice that x plus 2 matches perfectly the other parentheses, the other x plus 2. That's not a coincidence. So now to get to your final answer, which is over here, what you do is you take these mini GCFs, the x squared and the 3, and you put them together, x squared and positive 3. And you multiply that with the matching binomial. You just write it down once, though. I know you see x plus 2 twice in this middle step right here, but you just multiply the mini GCFs by it once. Really what we did here is we factored a x squared plus 3 out of this equation because they each have a common factor of x plus 2. All right, so noticing that the terms in parentheses are the same, notice the terms in the parentheses are the same, like we just talked about, x plus 2 and x plus 2. This should always be the case when you factor by grouping. If they're not, something's wrong. And these are going to cook up, well, or the other suggestion would be that it's not possible to factor by grouping. But the ones that we do here in this class for the near or long-term future are going to be factorable by grouping. So if it doesn't work, check what you factored out. Check your math. All right, let's try this. So group the first 2, group the last 2. You can take an x squared out of the first 2. And when you're left, what you're left with is x, right? Because x squared times x gives you x to the 3rd. And then x squared times what gives you negative 3x squared? Be negative 3. What I kind of did there, folks, is instead of doing the division, dividing by x squared, I kind of did multiplication instead, figuring out what works. Whatever works for you. Plus, what can I factor out of the second parentheses? You can factor a 4 out of that, so you're left with x minus 3. Notice x minus 3 and x minus 3. That's not a coincidence. So what you do then is actually, and I misspoke in the step above, but it means it works the same. We're actually factoring an x minus 3 out of this, so you're left with x squared plus 4. But really what most students remember is once you have those matching binomials, you really just put the x squared and the 4, those mini GCFs, together and multiply it by x minus 3. There we are. Let's try the next one. Parentheses, parentheses. Oh, now as I start making my next parentheses, notice this 6x is negative. And so when I put a parentheses around there, I need to make sure the negative sign is by the 6. So we're going to do an add the opposite or chop slash and make this negative sign large so that when you put parentheses there, you can still tell that the 6x is negative. All right, so what can we factor out of the first pair? It'd be a 5 and an x squared. And you're left with 2x minus 5. What can I factor out of the next, or the second pair of parentheses? Some people would say 3, and 3 is a good answer. However, if I factor out a 3, if I divide by 3, what's left in the parentheses is a negative 2x and a positive 5. And if you think about it, or if you visualize that, or if you wrote it down, negative 2x and positive 5 is opposite what I've got in the first parentheses. So that's not going to work because these parentheses have to match. So instead of factoring out a 3, factor out a negative 3. Let me make that negative sign more clear. A negative 3. Because now a negative divided by a negative 6x divided by a negative 2, negative 6x divided by a negative 3 is a positive 2x. And beneath this red arrow, 15 divided by negative 3 is negative 5. So now my parentheses match. So I put my mini GCFs together. It's 5x squared. And then again, this 3 is negative. So 5x squared minus 3 times 2x minus 5, that common factor. There we are. There's the final answer. And the cool thing here again, folks, is if you check this, you can check this very easily by taking your answer and, oh no, I don't know, we did Turkey Day competition. I don't know what else is going on there. My son wrote me a poop card. How we can check this is by foiling this together, like we practiced in 4.1. If we foil this together, you better get that polynomial. If you don't, there's another goof. But that's the cool thing about factoring. You can check it by multiplying and make sure you get the original polynomial. All right.